we will do some questions that is related to sum of n terms. Question number 1. Find the sum of all odd integers between 2 and 100 divisible by 3. That is, find the sum of odd integers, all odd integers between 2 and 100 divisible by 3. Now you see the solution of this question. That is solution. In between 2 and 100, the odd integers are, that is 3, 9, 15, 21. Last term is, that is 99. It means we have to find the sum of this sequence. It means that is odd integers between 2 and 100. You know already this sequence is given in AP because difference between two consecutive terms is 6. You know 9 minus 3, that is 6, 15 minus 9, that is 6, 21 minus 15, that is 6. But first of all, we have to find the number of terms in this sequence. But in this sequence, the last term is given 99. It means L, this is 99. Common difference is given, that is 6. And first term is given 3. But we have to find the number of terms before finding the sum of n terms of the AP. It means L is equal to, you know this formula, A plus n minus 1 into D. L, that is 99, A is given 3, a plus, n we have to find, and D is given 6. Therefore, we get the value of n minus 1 is equal to 99 minus 3 upon 6. It becomes 16. Therefore, n is equal to 17. But we have to find sum of n terms. Because of this, I just use the formula for sum of the n terms. You know, Sn is equal to n by 2, that is first term plus last term. But n is given, that is 17 by 2, and first term is 3 and last term is given 99. Therefore, we get Sn is equal to 17 by 2 into 102. It becomes 17 into 51. This is Sn. Then we get 867. This is the method to find sum of n terms of the AP. Now we do the next question. That is, find the sum of first 20 terms of an AP in which third term is 7 and seventh term is 2 more than thrice of its third term. This is the question, but you just see the solution of this question. In questions, there is given third term is 7. It means, you know, T3 is equal to 7. It means T3 is A plus 2D is equal to 7, equation number 1. And seventh term is 2 more than thrice of its third terms. You know already, seventh term is 2 more than thrice of its third term. That is, seventh term is A plus 6D is equal to 2 plus 3 into A plus 2D. Therefore, we get here, that is A plus 6D is equal to 2 plus 3A plus 6D. This and this gets cancelled. We get minus 2A equal to 2. It means A equal to minus 1. This is the second equation. Put A equal to minus 1 in equation 1. Then we get minus 1 plus 2D equal to 7. Therefore, D is equal to 4. It means A is minus 1 and D is 4. But we have to find the sum of first 20 terms. Therefore, the sum of first 20 terms, that is S20 is equal to 20 by 2. This is first term, that is 2A plus n minus 1 into D. Because in this question last term is not given, because therefore I am using the formula n by 2, 2A plus n minus 1 into D. But n is given 20, therefore 20 by 2 that is 10, A is that is minus 1, and D is equal to 4 plus that is 20 minus 1 into 4. Then we get 10 into minus 2 plus that is 19 into 4, 76. It becomes 10 into 74, that is 740. This is S20. It means sum of the first 20. Again, you see the next questions. That is the sum of first 4 terms of an AP is 56. The sum of last 4 terms is 112. If first term is 11, then find the number of terms. Then solution of this question is like that. According to question, that is the sum of first 4 terms is 56. It means you know already. That is first term is A, second term is A plus D, third term is A plus 2D, and fourth term that is A plus 3D. This is equal to 56. Then it becomes 4A plus 6D is equal to 56, equation 1. Again, there is given the sum of last 4 terms. It means the last term is A plus n minus 1 into D. Then the second last is A plus n minus 2 into D. Third one is A plus n minus 3 into D. And fourth one A plus n minus 4 into D. And this is equal to 112. Then A plus A plus A plus A, it becomes 4A plus, that is, you can take D common from here. Then we get n minus 1, n minus 2, that is n minus 3, and this is n minus 4 is equal to 112. Then that is 4A plus D into 4n minus 10 is equal to 112. That is equation number 2. But in question, the first term is given 11. It means A is equal to 11. Put in equation number 1. But A is given 11. 4 into 11 plus 6D is equal to 56. Then 6D is equal to 56 minus 44. It becomes 12. Then D is equal to 2. But we have to find the number of terms of this series. In that case, we have to put A is equal to 11 and D is equal to 2 in equation 2. Equation 2 is given 4A plus A is given 11. It means 4 into 11 plus D is 2. That is 4n minus 10 is equal to 1. Then to solve this, you can get the value of n, that is 11. This is the answer. Now we see the next question. If the mth term of an AP is 1 by n and the nth term is 1 by m, so that the sum of mn terms is 1 by 2 mn plus 1, where m is not equal to n. Then solution. Mth term, it means Tm, is equal to 1 by n. It is A plus m minus 1 into D, that is 1 by n. Again, nth term is 1 by m, that is A plus n minus 1 into D is equal to 1 by m. Equation 1, equation 2. Now you subtract this, first minus second, we get m minus n into D is equal to 1 by n minus 1 by m. Therefore, D is equal to 1 by mn. Put in equation 1. Then we get A plus m minus 1, 1 by mn is equal to 1 by n. Then A is also is equal to 1 by mn. But we have to find the sum of mn terms. It means Smn is equal to mn by 2. That is 2A plus mn minus 1 into D. Mn by 2, that is 2 into 1 by mn plus mn minus 1 by mn. It becomes mn by 2, that is 1 by mn plus 1. This becomes mn by 2, that is mn plus 1 upon mn, gets cancelled by this, that is 1 by 2. This is mn plus 1. This is the Smn. Question is, if S1, S2, S3 up to Sm are the sum of the n terms of MAPs, whose first term are 1, 2, 3 up to m, and common differences are, that is 1, 3, 5 up to 2m minus 1 respectively, so that S1 plus S2 plus S3 up to Sm is equal to mn by 2, that is mn plus 1. In this question, S1 is the sum of first n terms of the AP, whose first term is, that is 1, and common differences are also 1. Therefore, suppose if you want to find the value of S1, in that case, you know in all APs, the number of terms is given n. Because of this, S1 is equal to, that is n by 2. This is 2a. It means 2 into 1 plus n minus 1 into d, that is 1. It becomes n by 2. This is 2 plus n minus 1. This is equal to n into n plus 1 by 2. This is the value of S1. In second AP, the first term is given 2 and common difference is given, that is 3. Then in second AP, that is the value of S2 is equal to n by 2, because in this AP the number of terms is also n. Therefore, n by 2, that is 2a plus n minus 1 into difference is given 3. It becomes, that is n by 2. This is 4 plus 3n minus 3. It becomes n by 2. This one is 3n plus 1. This is S2. In S3, the first term is 3, but difference is 5. But number of terms, that is n. Therefore, the value of S3 is equal to n by 2. This is 2a plus n minus 1 into d. Then it becomes n by 2, that is 5n plus 1. This is the value of S3. Similarly, you can find Sm. Sm, in this AP, the number of terms is also n. Therefore, n by 2, that is 2a, but the value of a is given m plus n minus 1 into difference is given, that is 2a minus 1. It becomes n by 2. This is 2m plus n into 2a minus 1 and minus 2m plus 1. Then 2m and 2m gets cancelled. It becomes, that is n by 2. This is n into 2m minus 1 plus 1. These are the values of S1, S2, S3 and up to Sm. But we have to show, that is S1 plus S2 plus S3 up to Sm is equal to mn by 2, mn plus 1. It means I just take the LHS part of this question, that is LHS is given S1 plus S2 plus S3 up to Sm. It means S1 is n by 2, that is n plus 1. Again S2 is given n by 2, it is 3n plus 1. S3 is given n by 2, that is 5n plus 1. It means LHS part is given, that is S1 plus S2 plus S3 up to Sm. But the value of S1 is n by 2, n plus 1. S2 is already given, that is n by 2, 3n plus 1. And S3 is n by 2, 5n plus 1. But the value of Sm, this is n by 2, n into 2m minus 1 plus 1. But in this series, n by 2 I just take common, that is n by 2. This is n plus 1, that is the first term. This one is 3n plus 1, this is the second term. And that is 5n plus 1, third term. And this up to 2m minus 1 into n. This is the last term of this series. But this series is also given in AP because the difference between the two consecutive terms will be same. Therefore, n by 2, the number of terms in this series is given m. Because of this, I just write the formula for sum of the n terms of the AP, that is m by 2. First term plus last term, it is n plus 1 is the first term, but last term is given, that is n times of 2m minus 1. By solving this, we get mn by 2, this is mn plus